Welcome to the Construct Innovate webinar series on sustainability planning and construction. My name is Jamie Goggins and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction, Technology and Innovation. This webinar series is kindly sponsored by Arup and supported by the Association of Consulting Engineers of Ireland, Engineers Ireland, the Royal Institute of Architects of Ireland and the Society of Chartered Surveyors of Ireland. This is a 7-part webinar series. Today, the focus is on circular economy and construction, maximizing resource efficiency and minimizing waste. As I said, it's part of a 7-part series in there, so one more week to go after this. We're very, very fortunate to have 3 outstanding speakers, 3 really eminent people in their fields. First speaker is going to be Martin Crook, who's Associate Sustainability Design Strategy at Arup, and he's going to talk about the Circular Buildings Toolkit, which they developed with the Ellen MacArthur Foundation. So a really, really useful toolkit that I've run many workshops using it before. So it's really cool, really good toolkit. Then we have Ingrid De Doncker, who's Head of Research Innovation at Future Planet, and she's going to talk about maximize efficiency and minimize waste. So, knows a lot about this in this area. So really look forward to that. And then a good friend, Professor Jerry Murphy, who's Chair and Professor of Civil Structural Environmental Engineering at University College Cork, and also Director of the MARI Research Centre. And he's going to talk about circular economy systems for wastewater treatment in there. So there's a lot of research, but also a lot of applied work in this with industry to really bring this to life. So really looking forward to our 3 presenters in there. So if you have any questions for any of our presenters, please do pose it in the Q&A function at the bottom of your screen. So please use the Q&A function, not the chat function at the bottom of the screen, and we will deal with all of the questions at the end of our 3 presentations. Okay, so without further ado, I'm going to hand over to our first presenter, Martin Crook, who's an associate at Arup, and he's going to talk about the Circular Buildings Toolkit. So over to you, Martin.
Thank you, Professor Goggins, and thank you, Kasia, and everyone for having me at Construct Innovate. I'm going to share my screen now, and it's going to be, as Professor Goggins mentioned, a walkthrough of the Circular Buildings Toolkit. So let me just bring this up here. Hopefully it'll appear in a second. And as this comes up, I should mention that this is a tool that is accessible to anyone online. So you can access this, and my hope is that by walking you through this tool today, you'll be able to use these different frameworks, strategies, case studies, all the different resources that are built into this toolkit for any of the projects that you might have in the future, running workshops, and just trying to understand how to embed circular thinking into projects in the built environment. So as you see right now, this is the homepage for the Circular Building Toolkit, which is developed, as Professor Goggins mentioned, with the Ellen MacArthur Foundation. If you scroll down, there's some videos and sort of explanation talking about circular economy principles that you can watch, and some comments from the Ellen MacArthur Foundation themselves, and some explanation about how circular economy helps our projects to improve from a climate and biodiversity perspective, and how they might be able to help your projects eliminate waste, circulate products and materials more effectively, and to be more regenerative from a natural resources and nature perspective. There's also this little roadmap we created. So depending on where you are on your circular economy learning, you can either decide to click into the Learn About Circular Economy portion of this tool. You can jump right into the framework. You can learn about strategies, etc. And so I'm going to actually walk through some of these during this presentation. And I'll also just mention that if you come down a little bit further, there's a little sort of summary of some of the benefits you see here: mitigation of risk on projects, capturing long-term value, etc. And there's some examples of projects that you can jump into that have used the principles within the Circular Buildings Toolkit. I'm going to start off by bringing you up. If you look at the top here, on the top bar panel here, you can see that there's the framework for the Circular Buildings Toolkit. If we click into that, you'll see this is really the summary of how our toolkit is structured. You'll see there's 4 columns here with the basic principles of the toolkit. Your first principle, build nothing. How can you be perhaps most circular is try to refuse the need to design any new construction. And here there's strategies below each one. So this one has the strategy of refusing new construction. The second one is to, in terms of principles, is to build for long-term value. So you have 4 principles here, increasing building utilization, or I should say 4 strategies, design for longevity, design for adaptability, and design for disassembly. The third principle of building efficiently has 2 strategies under refusing unnecessary components and increasing material efficiency. And finally, building with the right resources. This is how you look to reduce the use of virgin materials, use less carbon intensive materials, use less polluting and hazardous materials, and try to design for nature through greater biodiversity embedded design. So within each of these 11 strategies that sit within the Circular Building Toolkit, you'll be able to click into one of these and apply them. Let's say, for example, you would like to apply the principle of design for disassembly. This sits under the building for long-term value. And I should say, building for long-term value, we try to put this in a somewhat sequential order here, where you would first think about what is the long-term value and then how you do that efficiently and how you select the right resources. It doesn't always go in that exact order, but let's say you wanted to think about how to design for disassembly. If you click on there, you'll see that this whole strategy comes up with a description and some information about this strategy. So there's, let's say, an overall qualitative impact level, but maybe more interestingly, you can see whether this impacts the different disciplines. So this seems to impact structural engineering and facade engineers the most. And there also are several KPIs, some key performance indicators for you to reference. And many of these are KPIs that are broadly recognized across not just Europe, but in many cases globally. But here, for example, you see EU levels indicators 2.4, which is a very commonly referenced document within the EU, talking about how to design for deconstruction in that case. And we list some benefits and challenges as well. On the side, you see some of the key actions. So in this case, because we're talking about how to design for disassembly, there's actions around developing reversible connections, allowing access to reversible connections between the structure and building services, and developing a disassembly manual document for the building. And you can actually click on these actions as well, and they break out into a greater description, talk about sub-actions, and references other tools you can use. So this is what makes it a quite powerful framework. You can dig quite deep into any one of these principles. Here you see all of these different actions all here at once. If you click on strategies and actions, you can even filter by element. So if you're talking about just architectural or MEP, building envelope, interior fit out, or different life cycle stages, you can actually filter the actions in that way as well. So that is a kind of very simple way to approach this framework, by thinking about what are the different strategies that are relevant in your context, and you can try to explore them and reference these different KPIs, some of which actually appear directly on these tiles under each strategy. So that's a really, I think, a useful thing. I use this all the time. Professor Goggins mentioned that he himself uses this regularly with his students, and I think that many of our clients at Arup have found this quite useful themselves, and we deploy it in many different settings as well, which I'll get into. Before I go any further, I'll also mention that under the case studies tab here at the top, that also allows you to look at and consider different projects that Arup has delivered around the world, and these could be potentially an inspiration in your case to try and understand sort of how we applied these different strategies of circular economy, and maybe you might even see some in your context or in your region. You see these are global. You can filter by country here as well as category in terms of whether you're looking at just a component or a project, etc. Or again, the different sort of shearing layers of the building, whether it's the site, the structural, the interior fit out, that's all there as well. So if, let's say you wanted to, you see this one that's kind of shiny and flashing here that always catches people's eyes. This is a project we did called Adapt. And this is a sort of a modular building system that we created for a startup called Future 2K, a really interesting project, which essentially wanted to create a very adaptable, flexible floor plan, which sort of use these different detachable modular components and allowed it to sort of somewhat organically assume the design or composition that the client needed, and could flex as demands and requirements shifted. You see here on the left, it mentions the different design strategies that were referenced here. So you see design for longevity, design for adaptability, and design for disassembly, which I did a walkthrough of just now. So hopefully that this project, you can also click and see some links to this project more specifically if you want to do a deeper dive with that project, or you can come out and review all the other projects. So there's a really long list of just fascinating projects, some I've worked on, and I can highly recommend this feature. Under tools, so yes, this is the Circular Building Toolkit, but there's also a list of other tools we reference here. Some of them are Arup tools that we've developed, like the Arup Carbon Digital tool. Some are external tools, like those from Medastar, or those from the EU levels, etc. So there's just a great, basically, catalog here of different tools that could be relevant to your context in the built environment, depending on what you're doing. And you see some of these are specific to, in this case, New York City. There's some building codes. There's some references to the European Union Green Deal, and this also the Circular Economy Action Plan, and new European Bauhaus. Of course, there's many things here that might spark your interest, and you can just click in and jump into those tools and use those to inform perhaps your approach. There's other resources here, which if you click on the resource tab, these are mostly some documents that Arup has developed. And I highly recommend reviewing these as well, because they kind of take a deep dive on several different topics. This one here, unlocking value in buildings, developing the business case for building circular. So this kind of goes into how to quantify the actual value that circular design brings to buildings. And we kind of break it down in a really nice interactive PDF. And this actually just came out this year. We have some that we collaborated with the Ellen MacArthur Foundation on, and I highly recommend these resources as well. Let's say you do want to use the Circular Building Toolkit in a workshop setting. There's this workshop tab you can click on, and you can either download this guideline, which Arup developed for a kind of step-by-step framework for how to embed circular design and this whole process and this whole framework into your workshop. There's also these strategy cards, which kind of spark and prompt discussions around different elements of that framework. And this is all available for you to come to this website here. And I'm sure we can post this in the chat later. But you can also, if you just Google Circular Buildings Toolkit Arup or just Circular Buildings Toolkit, I'm sure it'll be your first hit, and you can come and you can download these strategy cards or this workshop guideline. Of course, there's many people who use this this framework directly, and if you want to add your own project, you can actually come in and register that you're using this project. And it's also a nice way for us to understand who's applying this project in their own context. And you can get in touch with us, and we can actually have discussions about how you can maximize the value of this framework in your own context. And there's also some Q&As here around, how you can apply it and what the different resources can do for you. And it's generally just also a place for you to kind of check in on some of the questions that you might have. But of course, you can reach out to our team directly, and or of course, reach out to myself, and I'd be happy to have a conversation. So that's the Circular Buildings Toolkit. And I'll just say, maybe in closing, this is a journey that we've been on at Arup, and I've been on myself. As I mentioned, I may have mentioned, I'm a structural engineer by background. I've worked in the built environment for about 13 plus years now. And we are really at Arup trying to always improve how best we can reduce the inflow of linear materials into our projects, and increase the share of circular materials, and of course, as part of this, then decrease the outflow of linear materials, and keep the materials circulating as much as possible within our projects or within the built environment generally. And that means improving how best we reclaim and recycle and reuse. And this toolkit is part of how we apply those principles. We're also very interested to learn from all of you. I know this is a cohort of people who are very invested in this topic, and I know Professor Goggins is as well. And so if you have any other topics or let's say other inputs you'd like to share with us in terms of how we can improve this toolkit, or other resources that you think we should look at, or any suggestions or things that we should take into consideration, certainly please do reach out to me. I know there'll be questions, and after this presentation by the three of us presenters here today. So please put them in the chat as we go, and I'll try and follow up with them at the end of this presentation. But if you have any other thoughts afterwards, please do reach out. And I just want to thank again Professor Jamie Goggins for inviting me here to speak on behalf of Arup, which is a supporter of the series and a partner. So it's been a real pleasure, and I'll pass back over to Jamie.
Brilliant, Martin. That's great, and great to run through a live demonstration of the toolkit. As I said, I've used it several times, and it's very straightforward to use. Really nice framework in terms of the strategies, easy to follow, but then under each strategies, there's several action cards that you can go through and get some inspiration of what you want to do. And I suppose what are you using for? What the end product is, you can effectively develop, for example, a circular economy statement for your project and help your client maybe to consider what sustainability aspects they might want to prioritize or embed within their project. So it can be used from the very, very early stage of the project, which obviously can have the most influence on, but right the way through different stages. And it can also be used, not just the client, but also within your own internal team, for example, within the consultants or within the construction team, or across the different team that's developing or delivering on the project. So there's loads of ways that it can be used, and it's it's a really, really powerful and useful toolkit. So if anyone's any questions for Martin, please do post them in the Q&A function at the bottom of the screen, and we'll deal with those after all three presenters are finished. So we're going to move on to our second presenter, Ingrid De Doncker, who's Head of Research and Innovation at Future Planet, and she's going to talk about maximising efficiency and minimising waste side. So over to you, Ingrid.
Thanks, Jamie, and thanks, Martin. It was really great to see. I'm just going to share my presentation, if that's okay. Can everybody see it?
Perfect.
Great. So my background, I come from the supply chain background, procurement background, and also I have been for the last 5 years for my sins involved in EU legislation in relation to reporting. So that's where my background comes from, and that's what I'm going to focus on a little bit. Actually, why do we need a path to zero? And this is not only for construction, but I just wanted to share that more and more, and this is the Potsdam Institute who is doing this, more and more we understand the data to measure and how we are negatively impacting on our nature and our climate. So in 2009, there's 7 boundaries that they assessed, and 3 already were crossed. So the tipping points already were crossed, which means that it's not a stable environment anymore. In 2015, we had 4 crossed, and this year, only last month, they did it again, and we now have 9 boundaries assessed and 7 crossed, which if you like trends, it's not a good trend. It's not the right trend to be. It's not only about the environment, it's also about people. So if we are living in a world with 2 degrees global warming, we will have 20% less of habitable land. And if we think climate refugees is a problem now, it will get worse. Just setting the scenes, one final setting the scene is really, really high level here. You might have heard about CSRD. You might have heard about the omnibus. CSRD was the reporting requirement, which now has been simplified. It was 1,200 data points. Now the omnibus is focusing on around 350 data points. CSDDD was everything to do with the due diligence and the action plans. That is on hold. And the eco-design, which I want to focus on today, for me, it's an enabler, and it completely supports what Martin was focusing on, the circular design toolkit, is still ongoing. It has been adopted, it has been approved, and implementation is in 2028 from then on. So what actually is the Article 5? I'm focusing on the Article 5 because it really is, for me, a game changer in the sense of what are the strategies we can do. And again, it aligns very much with Martin. So it forms the operational core of the legislation, and it makes the eco-design actually mandatory. So we're talking about performance measurements, and we're talking about information measurements, and it's all to do with durability and reliability. It has to do with resource efficiency, the circularity potential, and the waste minimization. And therefore, when I saw the context of today, I said, what better way to quickly deep dive and then to come back into, and what does this mean for your supply chain? So the first working plan has started early this year, and the below are the products that they're focusing on. You can already see for construction, iron and steel, aluminium, paints, coating, oils, energy-related products. They are working on defining the performance and the information requirements. And this probably aligns very much to what Martin has shown, but this is the Article 5. These are the eco-design requirements. So anytime a company will develop a product or design a product, redesign a product, these are the questions that we should ask. What is the recycled content? And there's going to be targets against it for each and every one of the sectors that it's informing. So that was a performance requirement. Sorry, just performance requirement. What are the performances of the product? And then there's also information requirement. And you might have heard of the digital product passport, very much aligned, or a cousin of I suppose, a more recent member of the EPD, the Environmental Product Declaration. But it's going to ask us to share all this information in relation to our material, how we design our products, the supply chain, how we manufacture it, the information related to the use, and this is greenhouse gases, it's energy usage, it's also biodiversity, and how we recycle. So the digital product passport is focusing on the information that needs to be shared with the product. And again, you can see the scanning code. Yes, there will be requirements for QRs because that's going to be a one source of truth. Now, there's an importance, you all know about the life cycle assessment. There's an importance of the life cycle assessment in Article 5 because a company doesn't live on its own. It's not a vertical company. It doesn't always produce from start to finish. It buys from previous suppliers, it sells to subsequent customers, and therefore the Article 5 and the information sharing and the performance requirement apply to the full life cycle. So the question then, and now I come back into my core expertise, it has to do with supply chain. Do you really know the flow of your product, the flow of the performance of your data? Do you know the impact of your products? So we know products and services most of the time flow that way. Financial information flows that way. And do we actually share the right information, and do we actually have it across the full chain? Because ultimately, what CSRD and what still the Omnibus asks us to do is understand our positive and negative impacts, risks, and opportunities. What is important for my business, what matters the most financially from a risk and an opportunity perspective, but at the same time, how am I positively or negatively impacting the environment or people? So this flow, very basic, but ultimately we need to start following the information, and we need to start measuring the performance. And then the question is, do you know your stakeholders, and do you know their sustainability focus? It's, the stakeholder engagement is core to everything we do. We are so dependent on suppliers. We can only have a financial vein in our business because of our customers. But do we actually know what they care about? Can we work together with them? Should we work more together with them? What is important to them, and where are they in relation to eco-design? Where are they in relation to maximizing their efficiency, minimizing waste? So for me, a company needs to absolutely collaborate across their supply chain, across their customers, so across their value chain. And there's many of them. And then ultimately, do you know where everything is coming from? This is not Ireland buying from Ireland. This is buying across the world. Do we see that chain? And if we don't, then we have work to do. Work to do in relation to gathering that information, work to do in relation to start measuring the performance. So what is your supply chain readiness journey? Is it an inconvenience of change, or is it actually a fear of what's next? And what I've learned with customers, and it's probably both, not a lot of people see change as a good thing. And for me, I always consider change as a good thing, because we can reduce our impact, our negative impact. We can increase our opportunities. And that's how I would love to share that with you. Now, across your life cycles, and again, stage 1, strategy, design, and concept, and I'm not going to go through all of them, but ultimately we need to design for the outcome. What are our financial and sustainable strategy? And in the EU regulation, they're using the double materiality assessment. You might have heard of it. You mightn't. Actually, what it is you identify what is most important to your business, and then you develop action plans around it. But before and after everything, we need to embed that circular design thinking, as Martin has explained. And don't forget to really collaborate with your suppliers. You need to integrate them in your stakeholder. You need to ask them what is important to them. You need to make sure that you fully understand who is a risk. So do heat mapping. Who is a risk? Who has value in your chain? Because working together is building that resilience. In your stage 2, your planning stage, make sure you embed ISOs, and I'm just focusing here on the 20,400, which is Sustainable Procurement ISO, but embed best practices from ISOs, from standards. There's so many wonderful standards out there that will guide you of how to do this. And it's step by step. Again, one of those is the toolkit that Martin has shown. There are others. know your suppliers. From my end, you need to make sure you know your suppliers and you assess them against what is important to you, what your targets are, and then verifying that with the KPIs and the data. But with the eco design coming out, learn what the data and the information and the performance requirement are that the digital product passport is asking for. And you don't need to do this alone. And again, that's why I'm happy to be here as well with everybody else. Share, learn, give people the right tools, give them the right data management training, give them the right skills so that we can all do this together. Stage 3, your construction execution. Again, for me, it's about targets to deliver. They need to be realistic, and use digital systems. Use them to automate as much as you can. But ultimately, it's people buy from people, people sell to people. So we all need to be on the same page. We need to be able to collect, work together, communicate our progress, not because we need to comply with standards or regulation. It's because it's the right thing to do. Then obviously after use, the operations and the maintenance, it really is about the long-term performance. It is about maximizing that asset value from one component, from one finished good, all the way into a full asset, a full construction, a full build, and implementing those resilient supply chains that you can measure against. And ultimately, sharing your digital records is key. So we need to aggregate them around the KPIs that matter to you across multiple facilities, so we can start trending, we can start using that information to continuously assess, are these still our impacts? Are these still our risks and our opportunities? Because ultimately we want our business to grow sustainably. And then stage 5, finally, deconstruction. So much to do there. Pre-demolition audits would be great. Material recovery, it's the full life cycle, and it shouldn't end. For me, there's value in waste. There's huge value in waste, and we haven't even started yet with business models, with adjusting our business model to capture that. But implement or work together with collaborative supplier networks. Again, Martin, so delighted I'm after you, not before you. So use the toolkit, learn from each other, share with each other. And for me, my final critical success factors is use technology. I know AI is coming fast and furious for everybody. It is a game changer. Use what is relevant. Use it to drive your insights and your business decisions so that you can measure across the entire life cycle of your product. That is with your suppliers and with your customers. Again, there's an imperative to collaborate, because there's no profitable business on a dead planet. So how can we all engage? It's not only about tools, it's about the hard skill development and training as well. Stay focused on what your business needs to deliver. It is not only about compliance, it should be about growing your business, and it needs to be seen as a competitive advantage. And for me, supply chain are your superpowers. You and your supply chain teams are absolute drivers. Once we get the value, we understand the value that lies within our supply chain, we can really accelerate the transformation from concept to reality. So final slide for me, how do we do it? We've developed a platform that looks at those strategy, big questions, how to identify and navigate impact, risks, and opportunities. And then how do we measure what is important to measure? So we configure that on the platform. But ultimately, for us, the focus is on the transformation, driving your action plans, transforming together with each other, and get everybody to get onto the one team to deliver to your targets. So that's it for me in a nutshell. Happy to take some questions after, and thanks for your time.
Brilliant. Thanks, Ingrid. That's a great presentation. I suppose, we have tools there, we have frameworks. You talked about some of those available. We also have the stick, which is some of the legislation that's coming in, but also you really highlighted the opportunities, like for opportunities for companies, and the best practices. Don't wait for the stick. Take the carrot. Those opportunities are there, and using those digital tools, upskilling and training and that to help you, get in front is, really core messages in there. And then, you talked about the digital the digital product passports that are coming in, and obviously we have the digital building passport that is coming in, so it all links in together, and these are all the requirements that are coming down the line of that. So if anyone has any questions for Ingrid, please do post them in the Q&A function at the bottom of the screen, and we'll deal with all the questions at the very end. Okay, so we're on to our third presenter, over to Professor Jerry Murphy, who's Chair and Professor of Civil Structural and Environmental Engineering at University College Cork, and also is Director of MARI, which is Ireland's Research Centre for Energy, Climate and Marine in there. So over to you, Jerry, talk about the circular economy in terms of wastewater treatment.
Thank you, Jamie. Can you see my screen?
Yeah.
Okay. So my name is Jerry Murphy. I'm the director of the MARI Centre for Energy, Climate and Marine, and my presentation is on circular economy systems for wastewater treatment. The MARI research group, of which Jamie is a valued member of the leadership team, has been in place for 13 years. We've graduated 215 PhD students in the area of energy, climate and marine. And the area that I work in is a subset of this. It's the circular economy, energy and environmental systems. And in this, we look at biofuels, biorefineries, e-fuels, e-refineries, and we look at sort of bioeconomy, e-economy products, such as hydrogen, methanol, ammonia, methane, microalgae, biochar, biofertilizers. So it's a relatively broad shop, but it's all about this circularity. And this is a menu that we tend to look at. So most of our technologies, and we're very technology driven, is on this map. And I might start in the bottom left. And I suppose an argument we would make is anaerobic digestion is part of a circular bioeconomy system. It's not like a wind turbine where you've one product. There are lots of products. And I spent 6 years leading a task within the International Energy Agency Technology Collaboration Program. And a lot of these were related to bioenergy and biogas. And we produced, I think I co-authored around 25 reports and lots of smaller case studies. But for example, Europe has this target of 25% of land will be under organic farm by 2030. And our viewpoint is if you have an organic farm, you need a fertilizer. You can't use fossil fertilizer. So we would see the digestate from anaerobic digestion supplying the biofertilizer to allow the crop grow. So in essence, the digesters here are being built for biofertilizer, not as such for biogas. Another area which is hugely important is that we have a target to replace 10% of natural gas with biomethane. So the biogas is upgraded to biomethane. The methane goes to the gas grid and CO2 is left behind, and it's almost pure CO2 and it's biogenic CO2. So it's renewable CO2. And at the moment, direct air carbon capture is around 400 euros a ton. So we would see this as the ceiling of the value on the biogenic CO2. And my colleagues in the anaerobic digestion profession would say they expect to make more money out of the CO2 than the methane. The last area of interest is the fact that biomethane may be used in hard to abate sectors. So we can run trucks 1,000 kilometers on a fill of biomethane. And there's very few other technologies that are available now that can run a truck 1,000 kilometers on a decarbonized pathway. Just trying to get on to my next slide. When we look at CO2, one of the things we have been looking at is that the carbon dioxide in biogas can be used for many products. And one piece of work we've looked at is putting biogas into a column at a pH of about 11. And then we have bicarbonate, which represents the CO2. And we talk about a bicarbonate-carbonate cycle. So we put harvested algae up into this column. It takes out the CO2 in the bicarbonate and returns carbonate. So in essence, we're growing microalgae off of the CO2 in the biogas, and we've designed this for small scale systems because typically upgrading biogas to biomethane is very, very expensive. It needs large scale. So we developed this for small scale systems. And in my local shop in Kinsale, where I live, microalgae, spirulina powder, sells for €3.89 for 100 grams, which is 39,000 euros a ton. So we see a valuable byproduct. As well as biomethane, we have this vegan superfood. We've also been looking at digestate and the idea of making a char. So we've carried out evaluations for clients of very large anaerobic digesters, and we've vast quantities of digestate. So the idea is, can we concentrate it? And we've looked at digestate separation into solid and liquid. From the solid, we can make biochar. From the liquid, we can make hydrochar. In essence, what we're doing is we're making particles of about 80% carbon. So this is char under a microscope. In the lab, we've used a muffle furnace, but in essence, it's a pyrolysis plant. So we put our digestate in an anaerobic environment under high temperature, and depending on the top temperature and the ramp up rate, we can tune this char for what we want it to do. So for example, here we have a char with a surface area of 390 meters squared in a gram. I mean, this is a fantastic number. It's a huge surface area in a gram of char. And this char can be applied to land to improve soil organic content, or it can be used to filter out contaminants. So we published a paper recently in the Royal Society of Chemistry on the roles of char. We can make cathodes out of this char. We can apply it to land. We can use it in batteries. It can be conductive, or it can strain out. And an area we're interested in is using wastewater as the water source for electrolyzers, where the biochar will stream out the contaminants. Again, in my local shop, char sells for €16 for 12 grams, which is 1.3 million euros a ton. So we can make activated char. So there are many, many values for the char, which is processed from digestate. Ireland has a very large challenge, as do many other countries over the coming years, to supply large quantities of renewable electricity. So within the Marai Centre, we've done a lot of work on offshore wind and onshore wind and PV, and looking at decarbonised strategies. Within the IEA, I published this report looking at using electricity to make hydrogen, methane, methanol, ammonia, and Fischer-Tropsch fuels. In essence, this would be a sustainable aviation fuel. So we get our hydrogen from splitting water using renewable electricity, and we get our carbon from biogenic CO2, such as from biomethane or an ethanol facility. So we're making renewable hydrocarbons, renewable hydrogen from electricity, renewable carbon dioxide from biomethane, or direct air carbon capture. And we have this roadmap in Ireland for an auction of 17 gigawatts of offshore wind by 2030. We also have 9 gigawatts of offshore wind. And as a country, we've never used more than 7. So we're going to have lots of installed renewable variable electricity, which causes problems for the grid. But it's a lovely challenge for us in that if you look at phase 3 up here in the auction pipeline, we've 2 gigawatts of private wire to be auctioned in 2025. And in the climate action plan, they're proposed for hydrogen. And one of these is expected to come ashore in Cork, so gigawatts of hydrogen coming ashore. So we've looked at this idea of biofuel and e-fuel. So we're bringing electricity into our fermentation processes. And what we have been looking at, this is a schematic of a microbial process in anaerobic digestion. You start with complex polymers, you liquefy them, you ferment them to volatile fatty acids, and then you have these archaea. So these are naturally forming. So if we look at 4.1, it's a hydrogenotrophic methanogenic archaea. It eats hydrogen from offshore wind, carbon dioxide from biomethane, and it produces methane. It's an exothermic reaction. So what we did in our lab is we fed anaerobic broth, hydrogen and carbon dioxide, and we got pure methane. It's a Methanothermobacter wolffi. So we have bugs that will break down hydrogen and carbon dioxide and make methane. We devised a system in our lab, a sequential system where hydrogen and carbon dioxide under pressure is recirculated around these continuous reactors. So we have 3 reactors. And then we built this in our lab. And so you can see R1, R2, R3, and in R3 we have almost pure methane. So we have 4 moles of hydrogen from offshore wind, a mole of biogenic CO2 from biomethane will give us more methane. And you may ask, why would we do this? Why do we want to make methane? And this is an application at a wastewater treatment plant. So we're looking at power to methane at a wastewater treatment plant that includes, for this biological methanation, an electrolyzer. And there's a facility in operation outside Copenhagen. It's called Biocat. Electro-Che is the technology provider. So what they have is they have a sludge digester at the wastewater treatment plant that has 125 meters cubed of biogas, of which 50 is carbon dioxide and 75 is methane. So they built an ex situ biomethanation process with those archaea that eat hydrogen and CO2 and form methane. And the CO2 becomes renewable methane. So we have the 75 meters cubed of methane in the biogas, plus the CO2 now becomes methane. So you have 125 meters cubed of methane, which is a 60% increase in the methane output. And you've also upgraded biogas to pure methane. And if we look at our stoichiometry, we need 4 times as much hydrogen as carbon dioxide. So we need 200 meters cubed of hydrogen to react with the 50 meters cubed of CO2. Hydrogen has an energy value of 3 kilowatt hours per meter cubed. So we have a 600 kilowatt hours of hydrogen, which is a 1 megawatt electrolyzer operating at 60% efficiency. So we put a 1 megawatt electrolyzer at our wastewater treatment plant, and that will upgrade our biogas to pure methane and increase the methane output by 60%. When we're trying to look at the circularity, Ireland has a lot of dispatch down. We're an island grid. We dispatch down 8.5% of renewables in 2022, 14% in 2024. And what happens when we get to 80% renewable electricity? There will be considerably more dispatch down of electricity. So we came up with this process looking at a wastewater treatment plant and trying to incorporate electrolyzers, ex situ biomethanation, and char. Now, I have a PDF which I've left with the conference organizers, and that will be available to you. I've gone through the analysis for those who want to go through the analysis, but in essence, we're looking at a 718 gigawatt hour per annum offshore wind farm, and we're taking 10% of that electricity to come into our electrolyzer that would be dispatched down. We're producing 7 million meters cubed of oxygen, which satisfies the wastewater treatment plant for 426,000 person equivalent. So this is Cork main drainage. This is a wastewater treatment plant I worked on in 1992. So we've sized an electrolyzer to match the oxygen demand of the aeration basin. And then we also have hydrogen at the wastewater treatment plant. So I have a calculation here, which I won't go through. But we're producing 14 million meters cubed of hydrogen at this facility, 7 million meters cubed of oxygen. We can run the wastewater treatment. We can supply oxygen to the wastewater treatment plant. And instead of pumping air, we're pumping oxygen. So we're reducing the pumping by a factor of 5. We reduce electricity by a factor of 5. So we're aiding the wastewater treatment plant in reducing its power requirement. We're then going to the sludge digester, which produces 1.4 million meters cubed of methane and 776,000 meters cubed of carbon dioxide. That carbon dioxide will be converted to methane. So we'll have pure methane from the sludge digester. And from that methane, we could power 100 compressed biogas trucks. The hydrogen from the electrolyzer goes into the ex situ biomethanation reactor. It requires only about 25%, and the rest can be used for whatever hydrogen is required for. So we could run 300 hydrogen trucks. So we have this circular system in our wastewater treatment plant where we're using offshore wind dispatched down to provide oxygen for an aeration basin, to provide hydrogen to upgrade the biogas to a transport fuel, and we can run trucks 1,000 kilometers on cryogenic liquefied biomethane. I'm not going through the calculations. But then we have this other concept of an industry producing byproducts, which are anaerobically digested. We make pyrochar. The pyrochar is used to upgrade wastewater, which will then be used in the electrolyzer, which makes hydrogen from offshore wind, which reacts with the carbon dioxide from industry or the anaerobic digester, and we can make renewable methane or methanol or sustainable aviation fuel. So we have a map that allows us to incorporate a wastewater treatment plant into the circular bioeconomy system, producing renewable hydrocarbons that can be used for shipping, for haulage, even for aviation. And some of the CO2 that's left behind can be used to make microalgae, which is a superfood. So that's an overview of how we would incorporate the circular economy system into wastewater treatment. Thank you. I hope that wasn't too confusing. Happy to take any questions.
Brilliant. Thanks a million, Jerry. So, I suppose having someone like Jerry who's so much passion around this area, but also understands processes and then down to the chemistry, the biochemistry, and so on in there. It's, you need that high level understanding and that to be able to bring all these systems together to be able to optimize opportunities and maximize opportunities around, how does the byproduct or the outcome or what might be seen as a waste as a potential as an input into the next phase and so on in there. So that powered X going, well, X means lots and lots of different streams. That electricity that we're not currently using in there. Well, what does that X mean? And you can see there that Jerry has found lots of different really good uses, both in terms of valuable uses, in terms of adding to value to the economy as a result of it, and then looking at the wastewater treatment side of things in there, how we can make our systems more efficient in there, and then using byproducts out of that system as well to add into the circular economy. So there's loads and loads of really, really useful stuff there. And I suppose the really good thing about some of this is that this is not just this might happen in 20 years time or 30 years time. Like Jerry's showing things that they've, some of these things that have been actually implemented in the economy, both across Europe and in Ireland and so on. So that science really driving those opportunities in the economy. So if anyone has any questions for Jerry.